Greetings to one and all. Today, we have gathered here to discuss the topic flat routing in sensor networks. So, let's get started. This is the outline of what this tutorial consists of. The first thing that comes into our mind while studying this topic is what is wireless sensor network. Wireless sensor networks are composed of a large number of sensor nodes which are densely deployed and wirelessly communicated to send and receive environmental information. Each node is equipped at least with one or more sensors, a radio transceiver, a processor, and a power supply section. These are small nodes with sensing, computation, and wireless communication capabilities, which are used to monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion, or pollutants. The major task of wireless sensor nodes is to sense and collect data from target domain, process the data, and transmit the information back to the specific sites where the underlying application resides. These sensor networks are coming handy in enormous amount of application these days. Wireless sensor networks have become an integral part of diverse applications such as environmental monitoring, military surveillance, and medicine by providing feasible communication, reliable inspection, and performing applications. Wireless sensor networks are also known to be the key to Internet of Things. In the present day, all the medical diagnostics are carried out with the help of wireless sensor networks. Not only these, there are several other applications in which wireless sensor networks is being used. Despite of all the powerful capabilities of these sensor networks, successful development of wireless sensor network is still a challenging task. Routing plays a very important role in wireless sensor network and should be handled carefully. Routing technique is needed for sending the data between the sensor nodes and the base stations so as to establish communication. Improper routing problems leads to decreased network lifetime with increased energy consumption. Various routing protocols have been developed to minimize the energy consumption and to maximize the network lifetime. These are few important terms related to routing of wireless sensor networks. The way that data and queries are forwarded between the base station and the location of the target is known as data dissemination and gathering. There are certain techniques to carry out the same. They are single hop and multi hop techniques. In single hop technique, sensor node exchange data directly with the base station. However, it is costly as nodes that are farther away from the base station may deplete their energy quickly, thereby limiting the lifetime of the network. Then comes the multi-hop communication technique. Data exchange between sensors and the base stations is usually carried out using multi-hop packet transmission over short communication radios. We are also aware about the fact that sensor nodes have short communication radios, so practically the multi-hop technique can only be feasible to carry out the data transfer. Moreover, it significantly saves energy and increases the network life. Now, let us look at this figure to understand these techniques more precisely. Here, the red circle depicts the base station or the sync station or the destination station where the information is intended to reach, while the green circles are the sensor nodes or the source station which consists of the information, and the aqua circles are the aggregation nodes or the intermediate nodes. You can clearly see that in single hop communication there are no aqua circles and communication is clearly carried out between the source station and the sync station. However, this type of communication is only possible over a short communication radius, whereas in multi-hop communication, the information transfers from the sensor node to the aggregation node to some other aggregation node and finally to the base station. So basically, the information hops from one sensor node to another, hence depicting multi-hop communication technique. Moving further, wireless sensor networks are classified into three routing protocols: flat routing, hierarchical routing, and location-based routing. In flat routing protocols, all sensor nodes participate with the same role in the routing procedure. So basically, all sensor nodes perform a single task of data transfer. However, in hierarchical routing, sensor nodes are classified according to their functionalities. The network is then divided into groups and clusters, whereas in location-based routing, a node decides the transmission route according to the localization of final destination and the position of some other nodes in the network. Here comes the most important topic of this tutorial: flat network architecture. Flat network architecture consists of protocols in which all nodes are considered pairs. It has potential for the discovery of multiple routes between communicating nodes for fault tolerance. Also, it has several advantages, including minimal overhead to maintain the infrastructure. Data-centric routing protocols, which are a specific type of flat network routing, use attribute-based naming, whereby a source node queries an attribute for the phenomenon rather than an individual sensor node. The first and foremost protocol that falls under flat network architecture is flooding and gossiping. Flooding uses a reactive approach whereby each node on receiving a data or control packet sends the packet to all its neighbors. After transmission, a packet follows all possible paths. Unless the network is disconnected, the packet will eventually reach its destination. Flooding is very simple to implement as it does not maintain any routing table. Also, it does not require discovering of any routes. Let us try to understand flooding protocol through the means of this figure. In the former figure, let us consider node A as the source node and node H as the destination node. Here, node A consists of a certain amount of information which it further passes to all its nearest neighbors B, C, and D in this case. Then, all the nodes B, C, and D further passes the information to their nearest neighbors F and E. As we can see that nodes F and E are now flooded with information, leading to the duplication of information. This procedure is being carried out until the information reaches the destination node H. The later figure is a simplified form of flooding protocol. Though flooding protocol is a data-centric protocol, it still faces certain disadvantages. They are traffic implosion, which is caused due to duplicate control of data packets being sent repeatedly to the same node, as we can see the case with the nodes F and E. Other disadvantages of flooding are overlapping problem and resource blindness. On the other hand, gossiping addresses the shortcomings of flooding. Each node sends the incoming packet to a randomly selected neighbor. The neighbor selected randomly chooses one of its own neighbors and forwards the packet to the neighbor chosen. The process continues iteratively until the packet reaches its intended destination or the maximum hop count is exceeded. Gossiping has certain disadvantages as well. The latency that a packet suffers on its way to the destination may be excessive, particularly in a large network. Causes time inefficiency primarily due to the random nature of the protocol, which in essence explores one path at a time. The second protocol that falls under this category is Sensor Protocol for Information via Negotiation, or SPIN. It is also known as Data-centric Negotiation Based Information Dissemination Protocol. The main objective of SPIN is to overcome the shortcomings of conventional protocols like flooding. The basic property of this family of protocols are data negotiation and resource adaptation. Data negotiation requires that nodes running SPIN learn about the content of the data before any data are transmitted between network nodes. To carry out negotiation and data transmission, nodes running SPIN use three types of message. The first type of message is advertise, which is used by the source node. The second message type is request, which is used by the intermediate or the aggregation node. And the third type of message is the data, which can be used by any node. Now, let us understand the SPIN protocol. In the first figure, node A is the source node. What SPIN protocol suggests is that the source node advertises the information to all its neighboring nodes, unlike flooding, where the source node directly sends the information to the neighboring nodes. After advertising is being done, all the nodes which require the information sends a request back to the source node for the information. Like here, D is the node which is requesting the information from node A. After receiving the acknowledgement for the request, source node sends the data to the node which requests the information. This procedure is being carried out several times until the information reaches the destination node. Figure 2 is the simplified version of SPIN protocol. Last but not the least is directed diffusion protocol. Directed diffusion protocol is a data-centric paradigm with sensor query, dissemination, and processing that provides energy efficiency, scalability, and robustness. In contrast to SPIN, in directed diffusion, the sink is the node that broadcasts the request for a specific data throughout the network in what is called as interest message. A gradient can be thought as a reply link pointing towards the neighboring node from which the interest is received. In the following figure A, termed as interest propagation, the sink node sends out the interest message to all its neighboring nodes related to the acquisition of data, unlike the SPIN protocol where the source node advertises the data information. In figure B, gradients are set up, that is, all the neighboring nodes that relate to the interest message sends back an acknowledgement to the sink node for data acquisition. In figure C, data delivery along selected path is being done, that is, the minimum length path is being reinforced and data is transferred from the source node to the sink node. Here we complete all the topics related to flat network architecture. Thank you. Have a nice day.